When studying specific heat in the classroom, it is popular to do the calorimeter lab experiment. The calorimeter in a classroom setting is usually done with two insulating cups, styrofoam cups. And what you're doing is you're trying to determine what the specific heat is of a given substance. A calorie is it's a measurement of energy or amount of energy stored. So it's related to specific heat. Remember, specific heat is the amount of energy required to change the temperature of a given mass of that substance. Calorie, it describes how much energy is present in a substance. And for commercial purposes, like on the nutritional facts on the back of a bag of potato chips, represents calories with the capital C. And in chemistry, this represents 1,000 calories with the lowercase c. And remember our review in physics, we're interested in joules, a measurement in energy. So this represents 4.18-ish, kilojoules of energy. A calorimeter is a device used to measure the amount of energy absorbed or released in a reaction. Now remember, every reaction requires a certain amount of energy absorbed or released, and this is simply taken by the change in temperature. So let's say that the company putting out this dessert says that it only has 10 calories per serving. The question is, does a particular dessert have fewer than 10 calories upon a serving? We'll say it's a serving of 1 gram. And given the specific heat of our bomb calorimeter of 8.15 kilojoules per Kelvin, and a temperature increase of 4.94. And if you remember, our formula for specific heat is Q, representing energy, is equal to MCAT, C delta T, MCAT. Something interesting to note, when students come across a question that provides you with all the information, and all you have to do is plug it in and put it out, it gives you temperature increase of 4.94. And then they say, well, how come it didn't give two temperatures? Why didn't it give a final and initial temperature? If you are given an increase or a decrease, that is your change of. So 4.94 is our delta T. Rather this be degrees Fahrenheit, Celsius, or Kelvin. So let's plug the values in and calculate our energy. When we plug our values in, we find that we'll get an energy is equivalent to 1 gram times our specific heat times our temperature increase is equivalent to 40.24 kilojoules. But kilojoules is not what the question is asking. It's asking us for calories, and that's when we refer to our conversion factors. If I have 40.24 kilojoules of energy, how much is that in calories? You just write out what's given, you make a fraction, and just like stoichiometry, you write on the bottom fraction what you want to cancel is kilojoules, and for every 1 calorie, capital C, I have 4.18 kilojoules of energy. And you multiply these two fractions, you get 9.62 calories. So the question is, yes, this tasty dessert is less than 10 calories.